Hello, this is AE357 Petroleum Technology. The class is given for January semester 2015. The textbook that will be used in this class is written by Professor Fahim and other two professors here. The book is called Fundamentals of Petroleum Refining. Well, about 11 topics will be covered in this class. The first part of gas and oil exploration will be given by our guest. He graduated from our school here. And then we will start the class with an introduction of the refinery and its compositions. And then the calculations of the thermophysical properties will be carried out in detail. After that, we will now ready for the goals of the refining processes. This will include the distillation, the thermal cracking and catalytic cracking, also hydroconversion. And then we will talk about one byproduct that is very important, and it can be generated and also be utilized in the complex refinery. The last one is about environmental concerns, meaning that we will learn how to treat acid gas and how to remove some undesirable traces. Well, petroleum is consisted of hydrocarbon in a wide range of molecular weights. They include organic and inorganic. Of course, main composition are organic one. When we're talking about the petroleum, it will cover both unprocessed crude oil and also refined products. This picture shows how crude oil looks like. They are composed of hydrocarbon, some contaminated compounds of sulfur, nitrogen, and oxygen, and also metallic one. We will revisit them in slide number 10. Well, before going to the refining process, we should know how expensive the crude oil is. And the price of the crude oil in 2010, back in 2010, the price of the crude oil used to shoot up to $150 a barrel. And when we look at these figures, last year, in about July, August, or September, the price is getting to decrease. Up to the moment, you can see that the price is about $50 a barrel, and it's decreased from $65 a barrel since last year. Last month. Well, you have to find out how big of the barrel unit is referred to. Well, what we want from the refinery are fuels that are applicable for different kinds of transportation vehicle. And of course, what we know at the moment, crude oil is unlimited of volume. So people have tried to find other powerful reactions to develop the low value. So people have tried to find other powerful reactions to improve other low valuable sources to be So people have tried to find other powerful reaction and then improve other low valuable sources to make it more valuable in terms of energy sources. These are some examples. Yes, we try to increase of using the non-fuel sources such as biodiesel from vegetable sources, and some of them try to develop the better methods to produce some kind of chemical from the tar sands or from the reaction of coal gasification or even Fischer-Tropsch. Another example is try to make the long-term plans for any renewable energies such as wind energy or thermal energies. Since the environmental becomes a big concern and there are more restrictions on the fuel properties, so some reaction, for example, the sulfurization or even the alkylation that try to improve the quality of gasoline. Those reactions are quite important, so we will cover in this class as well. This is just to let you understand how to produce clean fuels. Okay, let's go to the refinery briefly. Many units. You can have distillation column, you will have hydrotreating, you will have cracking process. Many units in different functions are presented in different colors. I just put the meaning in different colors here. Let's go to the process briefly. Crude oil, after heated up, is passed to desalter. This unit is to remove some moistures and also salts contained in the crude oil. After that removal, it will pass to furnace and then heat up again to 400 to 500 degrees Celsius, and then it will pass to the separator. These two separator in color, what we call is atmospheric distillation or atmospheric crude fractionator, or the vacuum distillation units or vacuum fractionator. And then we will have some unit to get rid of some contaminants like sulfur, nitrogen, and oxygen. It will present in the blue one. And then some of them can be cracked. We present those units in green one. Some units have pink color here, which represent the upgrading units. Before, all products from those units here are sent to the gasoline pool or blending section before distributed. And these block diagrams showing the process of refinery, which is similar to the previous slide. Please look at the product that we try to classify in different way, in different pattern compared to the previous slide. You will see gas in the top part, gas products in the top part, and then later on we will have gasoline, and then we will have some fuel oil like jet, kerosene, and other fuel oil. diesel, for example. And then on the bottom part, the products are just like the one that thicker. For example, lubricants, greases, and wax. I try to put different colors here as well. The way to classify will be different from the previous one. We looking in terms of physical process, chemical process, and thermal process. So it depends which one you are more familiar to remember. In the model refineries, the production is based on physical and chemical techniques. For the physical techniques or separation, we are using the physical properties of boiling point and solubility to make the product more refined. And for the chemical technique, we can classify into ways. One is by thermal and one is by catalytic processes. For the thermal process, there are some reactions takes place to crack a larger molecule and making more products in smaller molecules, while the catalytic processes require some reaction on the catalyst to remove some traces or upgrade the product. So the whole idea of using these two techniques are we try to produce more volume of the fuel oil. We try to upgrade the product to meet the regulation, and we try to release less pollution to the environment at the end use. When we talk about the products of the refineries, one way to explain this is to put them into the diagram of average carbon number per molecules and versus to hydrogen and carbon ratio. For example, we have the crude oil starting at the carbon atom of 25, and we have the gasoline products which has the carbon atom average per molecule at about 8 to 10. Hydrogen to carbon ratio is about 2.2. So look at this diagram. You can see that there are two reactions may involve to produce more gasoline, which are cracking and also hydrogenation. So it means you try to put more hydrogen on the molecule of the crude oil composition to have higher hydrogen and carbon ratio. The same thing in terms of making LPG from the crude oil. So there's still two reactions involved. The higher portion of the hydrogenation should be take place to get more LPG from the crude oil. Well, in refinery, not only gasoline and diesel or any fuel oils, but also the other chemicals are interested because some of this can be used as a feedstock for other useful intermediate chemicals in downstream manufacturing. For example, you can see that we can have syngas produced from the residues of the refinery and used for produce methanol and some products of hydrogen and also carbon dioxide. Okay. And also we can produce cumene from benzene and C3 received from the process here. And then we will use that cumene to produce phenol, bisphenol A consequently. Now come to the composition of the crude oils. There are three main classes of the hydrocarbon. These are saturated hydrocarbons, unsaturated hydrocarbon, and aromatic ones. In saturated hydrocarbon, we are talking about carbon-carbon single bonds and can be split into parafins, or as we known before as alkanes. And also the other kinds of saturated hydrocarbon is cycloalkanes, or what we call in the refinery is naphthalene. While the unsaturated hydrocarbon is also known as olefins in the refinery process. In this table, you can see that the element which is composed in the crude oil is majority to carbon, and the composition based on weight percent is about 80 to 90%. This slide shows the detail of saturated hydrocarbon, unsaturated hydrocarbon, and aromatics. For the parafins, it's just an alkanes which have the carbon atoms are interconnected by the single bond. So you can see that the example can be as N-parafins and isoparaffins. When we look at the naphthenes, this can be called as the ringed paraffins or cycloalkane or cycloparaffins. So you can see the ring composed by all single bonds. How about aromatics? You will have the 6 carbon ring with multiple bondings, and also the olefins, which is usually not found in the crude oil, but at least they will produce along the process. In the element composition of crude oils, not only carbon and hydrogen are found, but also some contaminants like sulfur, nitrogen, oxygen will be present. So let me talk about the sulfur compounds here. Sulfur content in crude oils vary from source to source, and of course, some place the crude oil may contain sulfur compound in the small amount and up to 10% by weight. In the composition of sulfur, the smell of the crude oil will be present. If the crude oil contains sulfur less than 1% by weight, we can name that crude oil as the sweet one, or low sulfur crude oil, or sweet crude oil. And in case that the sulfur content is higher than 1% by weight, that crude oil will be named as a sour crude oil. Not only the element sulfur will be found, but also the sulfur may be present in may be presented in the hydrogen sulfide or carbon oxygen sulfur complex. And also they can mix in the complex of inorganic forms. This is a kind of sulfur that will be formed with other hydrocarbons. You will see sulfur in terms of mercaptans and also thiophenes. This is the thiophene type. So usually sulfur will bond in the carbon-hydrogen ring, while the mercaptan is based on the straight chain or isoalkane type. As you know that sulfur should be got rid of from the crude oil during the process, because some chemicals here, because the sulfur complex, the sulfur compound here act acidic and can cause the serious corrosion in the process. Oxygen compounds can be found in different forms, for example, alcohols, phenols, and carboxylic acid, ester, ketones, like this. And of course, some of these act acidic, which is not good to the downstream process, so they also needed to be removed. In terms of nitrogen, the nitrogen compounds in the crude oil is not good as well for the engine, since it can cause gum formation, and the compounds of palladies are quite strong in base, which can cause the corrosion to the downstream process as well. And in this slide, I have put the terminologies of alpha-asphatic crude oil, so you have to find out what does it mean on these terminologies. The metallic compounds are accessed in all crude oil types, but not very high concentration, and it must be reduced to avoid any operation problem and to prevent them to form the contaminating in the product. Not only that, all metallic compounds can poison to the catalyst in any hydroprocessing and catalytic cracking. The presence of the metallic compounds can be accessed in crude oils in both terms of inorganic water soluble salts and also oil soluble organometallic compounds. And of course, in the inorganic water soluble salts, sulfates and chloride of sodium, potassium, magnesium, and calcium, these are required to remove in desalting unit. We will talk about this in chapter 4. In case of oil-soluble compounds, mercury, vanadium, nickel, arsenic, and cadmium may be presented in a trace amount in the crude oil. We need to have some unit to remove those. Otherwise, a very little amount of those will damage the catalyst downstream or even corrode in terms of amalgam formation. and that may block the flow of the crude inside a small pipe diameter. The last one that we have to mention, one of crude oil compositions which is not very useful but we have to concern is asphaltenes. Asphaltenes usually found in fine particle or fine solid, and it is hard to melt. The molecular weight of asphaltenes can be up to million, and since because it is in solid form, it can cause the deposition on the heating surface or even deposit on the catalyst pore. And we have to remove asphaltene out, otherwise we may face the transportation problem. Now we come to the products of the refinery. This is the diagram showing on the left hand side is the boiling range, and also on the right hand side is the number of carbon atoms composed in different products. For example, diesel fuel is composed of carbon atoms between 10 to 20 and has its boiling point between 180 degrees Celsius up to 350 degrees Celsius. What you can observe from this diagram are that the first one, the product cannot be composed by one pure chemical. The second one is the cut point between each product may have some overlapping. That's why it is very hard to have the direct measurement for their properties. So we therefore need a pseudo method to indirectly evaluate their properties. Now in these two last slides, I would like to mention about the properties that need to differentiate or understand about the crude oil and the product. In the first slide, in this slide, here 4 important properties need to be mentioned for the crude oil, starting from 2 boiling points distillation curve, ASTM distillation curve, and also if you would like to have the detail, you may have to analyze those products by gas chromatography, and this will give you some which quite important, since you can use that number to classify what kind of crude that which you are using in the refinery. And these API gravities will be based on this equation. Of course, first, after a measure for the specific gravity, you can use this equation convert to API gravity. In this slide, we are talking about the product properties. Of course, we are talking about the octane number, cetane number, and other viscosity, pour point, freezing point, aniline point, or flash point, which are very useful. And the properties here are quite useful to make a judgment that whether they are appropriate to the engine we are running. I think that's all for chapter 1 and chapter 2. You have to study further in the textbook, and then we will come to the class and explain in more detail. Thank you for watching. Goodbye.